All right, let's find the expected value and the standard deviation of a probability distribution. So we have a four-sided dice. It's twice as likely to land on a two than any other number. The other numbers share the probability uniformly. So those all have the same probability. So the one, three, and the four are all the same. The two is the heavy. It's twice as likely as any of the others. How many twos should we expect to find if we roll it three times? And then what is the standard deviation for the number of twos out of these three rolls? So if I want to find the expected value or the average of a probability distribution, I need to find all the events possible and their probabilities, because the expected value or the average, same thing, is the sum of all of the events possible multiplied by their probabilities of occurring. So if I'm trying to find the expected value of the number of twos, then I need to count the number of twos. So I could have zero of them, I could have one of them, two of them, or all three rolls, right? Because I'm rolling three times. So all three of them could be twos. And the probability, so those are my events, the probability of each event occurring is given to us by the binomial probability distribution. So this is given to us by n c x, the probability of a success happening x times, and a probability of failure happening the other times. So you'll do this equation for each one of these events, 0, 1, 2, and 3, and you'll find probabilities of 0.216, 0.432, 0.288, and 0.064. So your expected value of the number of twos is going to be the sum of all the events possible multiplied by the probabilities. So you could have 0 twos, and the probability of having 0 twos is 0.216. Right? That's the event. And this is the probability of that event. Now I add to it, I could have 1, 2, and the probability of me having 1, 2 is 0.432. 0.432. I then add the event of me rolling two twos. That occurs 0.288. Or all three rolls could happen, but that's not very likely, 0.064. And when I do this, I find an expected value of 1.2. So if I were to roll this dice three times and count the number of twos, then if I did this over and over again, the average number of twos I would get would be 1.2 out of three rolls. So now I need to find the standard deviation. Oh, before we move on, let's talk about the shortcut. So another equation for the average or the expected value of a binomial probability distribution, so you can only do this with a binomial probability distribution, it is the number of attempts times the probability of success. So you're rolling three times, a probability of a two happens 2/5 of the time. That is 6/5, or exactly 1.2. So you get the same thing. It's just a shortcut if you can remember that equation. All right, now to find the standard deviation. So the standard deviation, I need this distribution. It is the square root of the sum of the squared differences between each event and the expected value, or the average. And I weight each one of these square differences with the probability of that event occurring. So I could have 0 twos. That's that right there. Now I need to subtract from that the average, or the expected value. So the expected value was 1.2. I then square it. And then I multiply by the probability of 0 twos occurring. That is 0.216. And now I add all of those. So plus, I could have 1, 2 minus the expected value of 1.2 squared, And the probability of having 1, 2 is 0.432. Ran out of room, I could have 2 2s minus the expected value of 1.2 squared, and the probability of 2 2s is 2.88. And finally, I could have 3 2s. I'm expecting, oops, not 1.4, but 1.2. And the probability of 3 2s occurring is 0.064. So remember, all of this is inside the square root. So make sure to perform that addition before you take the square root. When you do, you'll see that the standard deviation is about 0.849. All right, and there's also a shortcut here. Your standard deviation for a binomial probability distribution can be given by the square root of n, the number of attempts, times p, the probability of a success, times 1 minus p, the probability of failure. So that would be rolling 3 times. A 2 happens 2/5 of the time, and a not 2 happens 3/5 of the time. If you do this, you'll see that you also get 0.849. So you get the same thing.